Well, good afternoon, everybody, and welcome to this webinar from the UK and Ireland Spill Association. This is specifically from our Plastic Pollution Working Group. We've got about 100 registered. We've got 35 online, so I think we have a good body and we'll crack on. Just a little bit about us. We're the trade body for marine and inland response companies in the UK. We represent contractors, manufacturers and consultants. And our accreditation activities on the inland oil and chemical spills. And we deliver the Maritime and Coast Guard Agency scheme for the accreditation of marine spill response organisations, which is run through our independent accreditation body, the International Spill Accreditation Scheme. So how did we get involved in plastics? Well, there are a number of spills which occurred in late 2019, 2020, and carried on through 2020, which affected the UK shoreline. None of them were big, so they weren't a national contingency plan incident, which would have been dealt with by under the MCA contract. So it was left to local authorities to deal with them. And what they found was they then they didn't have the capability, so they contacted the Environment Agency, who didn't particularly have a solution, and it left and in many cases, I think the plastic then disappeared because nobody attended to it, and therefore it disappeared back into the ocean from which it had come, in the hope that it would arrive on somebody else's beaches. Well, that's an inadequate, and everyone would agree that's an inadequate way of dealing with a plastic spill. So the Environment Agency asked our association if we could develop with them a nationwide response plan so that when plastics do arrive on beaches, their removal could be safely and promptly arranged. And that was really the catalyst that formed the Plastic Pollution Working Group. It soon became obvious to all its participants that this was useful and solved a problem, but clearly the mission was much larger. So we grew into a multidisciplinary group of member companies, regulators, academia, and since then it's certainly grown legs. Now, when the MV Express Pearl incident occurred off Sri Lanka in May 2021, it involved a number of our group's members, particularly Oil Spill Response, ITOF, and CFAS. And as this is the most recent incident where there was a significant spill of nurdles with awful consequences to marine life, the shoreline, local environment, and the fishery, it was clear that there's a lot of learning to come from this. And it can therefore build upon other recent incidents which have impacted European shores. And the MSC Zoe lost 345 containers in the North Sea in January 2019. Of which the contents of several impacted the Wadden Islands, with many of these containers sinking, but the remainder also impacting Danish and German shores. And one of our group members, Ambipar Response, was heavily involved in this. And also our members have dealt with other smaller incidents, and from which there is learning. And our belief as an association that we should be sharing this. So consequently, with this live learning going on and experience building from the Express Pearl incident, the group decided that we should share what we learn by collaborative production of a series of best practice guidance documents and supported by webinars. And earlier this year, the group committed to a series of goals which we completed by the end of Q1 2023. And so these are what we are aiming which are the goals that we're working our way through. And you can see them on the screen there. Now, the members of the group, which is sort of chaired, I suppose, and coordinated and chivied along by the association, are Oracle Environmental Experts, who are actually going to deliver this webinar, Oil Spill Response Limited, who deal with events internationally, Ambipar Response, who deal with events internationally, RSK Raw Limited, which is part of the 145 company RSK group, which works internationally, CFAS, which is a government-funded marine science laboratory up in Lowestoft. ITOF, which is based in London, but responds to incidents related particularly to tankers, but to other pollution incidents worldwide. And of course, our own Environment Agency. So while I've been reading this, our members, I hope you've read those, what our goals are. And this is the second chunk of our goals, which we are going to work through. And to each of these, we're producing a guidance document, and we're then also doing a supporting webinar. And the object is that both of these will then be posted into our website under our new section called Working Groups, and in particular, these will be under the Plastic Pollution Working Group. So you'll be able to access the guidance document plus the supporting webinar whenever you feel able. So this webinar is going to help deliver goal 1. Understand the problem, understand its sources, pathways and impacts of plastic pollution from rivers and the ocean. And it's going to be delivered by 2 handsome chaps who both got moustaches because they're participating in a fundraising campaign across the world called Movember. So they've still got them. I guess they'll be shaving them off in a couple of days. So on your screen, you'll be able to see to the left, Dr. John Burton, and to his right, his sort of lead in this project, Josh Duran. So I'm going to shut up and allow them to get on with producing what is actually a really good webinar. So we'll take questions at the end, but if you feel that you want to raise something, stick it into chat, and I'll field these and host these at the end. And at the end of the questions, we'll open it up. So if anyone has anything they want to say, please say it. So I'll stop sharing my screen and allow Josh to share his. Thank you.
You're kind, Mark.
Can you hear us all right, Mark? Can you hear us okay, Mark?
Yeah, if you can just go to full screen, that'd be great.
Yeah. There we go.
Okay, thanks everyone. I'm John Burton. I'm the MD of Oracle Environmental, and we are one of the members, as Mark has said, on the Plastic Pollution Working Group that's been arranged through UK and Ireland Spill Association. And we're going to talk to you today about goal 1 of the Plastic Pollution Working Group, which Mark has touched on there. And that's just a small part of the work that the group are carrying out, and is really the kind of foundation for the rest of the research and development that the group's going to be carrying out for the remainder of this year and certainly the first part of next year as well. So the vast majority of the work for this webinar has been done by Josh here. So I'll pass over to Josh now.
Nice one. Yeah. Hi everyone. Thanks for attending today. So yeah, I'm Joshua Duran, environmental consultant with Oracle Environmental Experts. I've got a background in marine biology, but I'm an avid surfer and scuba diver, and whenever I'm on a beach, I'm always cleaning up litter. So this is right up my street, basically. So yeah, as Mark mentioned, what the aim of this webinar is to present an understanding of the plastic problem. So this is kind of really a signposting exercise to identify those sources, kind of where the plastic's coming from, the pathways of how that's getting into the oceans and into our freshwater environment, and also what impacts that has as well. And then we'll touch on really what's next for ourselves and the working group after this. So understanding the problem. So defining definition on plastics, and majority sort of defining those microplastics. So as you can see from this diagram here, there's quite a lot of disparity in the literature of what microplastics actually are, but there's a sort of general consensus that anything larger than 5 millimeters is considered as a macroplastic. So your sort of standard plastic bottles and your face masks that you're getting on your beaches. Anything between 5 mil and 1 micrometer is considered microplastic, and then anything less than that is then considered as sort of nanoplastic. For the reasons of the group, what we've looked at is focusing on those microplastic as a something to investigate, basically. So within that, there's a lot of differences between those sizes and those shapes. So that can be either from what we consider a primary microplastic. So that's something that's built or sort of made as feedstock for large materials. So pre-production pellets, which are otherwise known as nurdles. But also that can come as forms of flakes, which are broken down pieces of macroplastics that we'll go on to. So here it basically shows percentage compositions of the sort of different polymers that you get within plastics. So on the right hand side, so that nurdles, glitter and microbeads, it's what we consider as primary microplastics. So anything that's normally around sort of 2 mil, a lot of these sort of pre-production pellets. As you can see here, their compositions are mainly from sort of 1 or 2 components. So you've got the polypropylenes and polyethylenes. But conversely, where you look at the secondary microplastics, the ones that have broken down from those macros, you can see that from those fragments, there's quite a large sort of spread of different components in there. So it's quite hard to tell obviously where that's come from. We're looking on the fragment, the thermoplastic rubber. So that's used obviously in the automotive trade, on using it in tires. So that could potentially have come from tire wear. And the acrylics as well, when you see in that film, that could be from the exfoliation of paints within on boat hulls. So that's what we sort of define as those two differences between microplastics. So one example of those fragments is actually one of the reasons, as Mark mentioned, the PPWG actually formed. So back in November 2020 and January 2021, sort of along the stretch of Blackpool up to Fleetwood, following sort of 2 fairly large storm events, there was this huge plastic strand all along the coastline. And as you can see from these photos, it's made up of hundreds and thousands of small little fragments of plastic, different shapes, sizes and colours. And obviously it's impossible to determine what that originally was. It may well have been a bottle, it may well have been a washing up sink. So it's obviously hard to identify where that's come from. There was sort of suspicion that it may have basically originated from the River Mersey and kind of made its way up. And yeah. So looking at those sources then, and one of the biggest things to sort of point out here, and sort of Mark's mentioned in the past, is that there's a lot that we need to do ourselves with cutting down on the single-use plastics. And if we don't agree to sort of those pledges of the reduction, we could be looking at 99 million tonnes of uncontrolled plastic waste entering into the environment in 2030. And to give you an idea, that's a dumper truck tipping a load of plastic into the ocean every minute of every day of every year. So obviously that's a vast amount that could be entering our environment. So from this can be what's broken down here on this diagram from either land-based or ocean-based sources. So silly little things like artificial turfs, so your 5G rubber crumbs that can come off those environments and then into the fresh water through the surface runoff. And that's where I mentioned beforehand with tire wear and also the abrasion of road markings, all entering our fantastic drainage systems and going into the fresh water. Also looking at from an individual point of view, from the cosmetics industry. Now, there was obviously a ban in 2017 with microbeads within exfoliating creams, but obviously those beads are still within the environment now, and I'm sure there's probably some products on the shelves in someone's house which have still got those in. Within sort of synthetic clothing and sort of the laundry washes, now in a sort of standard a clean when you put your washing in, that can release millions of microfibers into the final drainage, and ultimately that then enters its way through into the wastewater. Now, there has actually been quite a lot of research that shows that up to 80% of microplastics are actually retained within those wastewater treatment plants, but we'll come on to that later, kind of what that means for them. And also industry. So at the moment, there's a forecast more than a double by 2050 of plastic production. So that's an increase of 756 million tonnes anticipated compared to the current, also in 2018, there was 380 million tonnes of plastic produced. So again, that shows there's a vast amount that we're still doing at the moment. And that's the idea of that loss of pre-production pellets, sort of those acute losses that we're finding from those factories. And then also agriculture and agricultural practices with using plastic films to cover over crops to increase that greenhouse effect, which again get integrated into the soils and potential runoff from there. Then looking at those ocean-based sources, so the fishing industry, I'm sure you've all been down to the beach and seen the sort of little green bits of rope along the shoreline. So obviously that they've been cut off from the nets, but the fishing industry has sort of been linked to one of probably the bigger sources of microplastics, because where you see these huge amalgamations of these fishing nets, not only is that a huge issue for sort of, I'm sure you've seen the photos of turtles and things being caught up in those, but even that small little bit of nylon rope can break down into millions of pieces of microplastics. So that's obviously a really large source, and that's straight into the environment. And then also looking at macroplastics as well. At the end of the day, all microplastics, well, those secondary microplastics are coming from those macroplastics. So they have a potential to break down from the UV radiation and physical weathering being battered around, and will break them down again. And then also shipping. So that is either from the loss of containers, and as I previously mentioned, with just the exfoliation of the paints on the holes, all come down to make these microplastics. So this is a bit of data that we got from the Southampton University, and we've currently got a group design project with them at the moment, investigating microplastic nurdles. And this illustrates in between 2020 and 2021 the number, or sort of the positions of recorded container losses from the IMO. Now, obviously, there's thought to be actually far greater than this, with a lot being underreported. And on average, it's thought about 1,380 containers are lost each year. And you can sort of see these areas which the group have highlighted here with quite a high amount sort of losses with it here, and we'll come on to those key areas later. So two fairly fun examples of cargo losses to show you. So this is a photo I actually took from Fleetwood from one of our trials, and it's a piece of Lego seaweed sitting amongst the rest of the natural seaweed. So back in 1997, there was a loss of 5 million pieces of coincidentally sea-themed Lego just off the coast of Land's End, which was coined the Great Lego Spill. And these pieces of plastic have been washing up on the shorelines for sort of years since, and also being brought up in fishing nets. And then a second example, which you may have seen in the Blue Planet 2 documentaries, was in 1992, there was a loss of nearly 29,000 rubber ducks and bath toys just in the middle of the North Pacific. And that again was then coined the Moby Duck. So these ducks were then identified across the globe well into the mid-2000s. And funny enough, was actually something that we researched in oceanography at university, because it was a fantastic model of all the ocean currents and illustrated those pathways. So again, this highlights that from these sort of the shipping influence of container losses. This data here, again from Southampton University, actually illustrates the top 10 primary plastic exporters and importers. And again, those orange areas you can see, especially sort of on the right-hand side, highlighting those key areas where we saw a lot of those container losses, and also the shipping routes. So interestingly enough, from the sort of most recent events that have occurred, so what in Sri Lanka, but we can also see that linked really nicely with two events that ITOF were involved in South Africa, and then also events up in the North Sea as well. So this kind of highlights those key areas, and that there are sort of a number of coastlines that could be quite at risk from the loss of cargo ships, containers. So coming on to that Sri Lanka spill. So back in May 2021, as Mark mentioned, Sri Lanka was confronted with this. There was an estimated 1,680 tons of low-density polyethylene pre-production pellets and so otherwise known as nurdles. So these washed up along the shoreline, so up to about 300 kilometres along the coast, all from sort of that express Pell container loss. Now, in that container as well, there was a lot of hazardous chemicals that also stored, and we'll come on to what that could have resulted in for the plastic as well. This was declared as an environmental disaster, and I said a lot of the responders from the UK spill were out on this event. As you can see here, a lot of people are just trying to rake the material and then sort of mass excavation works. So from sort of two members that went out to the incident, you can see that we're just using sort of a lot of manual techniques of recovery and sieving methods that were sort of determined the best to try and treat this pollution. So looking at the pathways of microplastics, so this diagram here from the National Oceanography Centre illustrates the sort of numerous pathways of how microplastics can get into the deep sea, but also shows those terrestrial, those land-based and the ocean-based pathways. So those, the white boxes are the pathways and the blue ones are receptors. So looking from the ocean side, as I spoke about before, we have those ocean gyres and currents. I'm sure you've probably all heard about the Great Pacific Garbage Patch, but as well, sort of those wind currents blowing plastics onto the shoreline. So a lot of the time plastics thought to float, and obviously not all plastics do float, especially when they've been biofouled by organisms, making them heavier and they sink. And I think ultimately this is the situation that happened up in Fleetwood, where there was a storm surge and then brought those plastics up from the deeper water onto the coastline. So there's that pathway there. But then as well, we can sort of look at those land-based pathways. So we sort of spoke about before with the sort of water runoff entering into freshwater environments, into the rivers and polluting the ocean. So there's the Ocean Cleanup is a brilliant website to look at, and there's a load of sort of interactive maps on there. And what this shows here is that the 1,000 most sort of polluted rivers which sort of cross the globe, basically to do with kilograms of plastic. And interesting enough, you can kind of see again those key areas sort of to the right hand side where there's been sort of high amounts of plastic being recorded, and again, ultimately they're all leading to the sea. So again, from Ocean Cleanup, this is one of their interceptors they have on the river in Guatemala. And that was from earlier this year. And you can see here just the amount of plastic piling up and sort of creating this dam. It's just unreal to think the amount that's there. And obviously that's all almost what we consider as macroplastics that have the potential to sort of break down further from there. So another pathway is we can actually look at from wastewater treatment and agriculture. So as I explained about beforehand, there's a lot of retention of microplastics within the sludge from wastewater treatment. And this is applied then onto farmlands. So a paper from Lofty suggests that 31 to 42 tons of microplastics, 42,000 tons of microplastics are spread on farmlands within Europe each year. And with the UK having the highest concentration, as you can see here, of 500 to 1,000 microplastics per metre per year spread onto the fields. Now, obviously, this is quite a worrying thought, that the fact that we're farming within these soils. And this just again illustrates the sort of microplastics all around, really. And the effects of eutrophication are quite well known, obviously with surface runoff. But then you add in the fact with all the microplastics that could well be on the farmland as well, going into the freshwater environment. And then again, there's another pathway into the sea. And then lastly, sort of on those pathways, looking at sort of that direct input into the ocean and from sewage outlets. So the photo on the right is a mock-up. That's not actually real, which is good to know. But this is from Surfers Against Sewage, and the map here actually shows water quality sort of within the UK, and that was actually from yesterday. But where those red X's are actually basically highlights that sort of sewage has been discharged within the last 48 hours. So, you know, with the high amount of rainfall we've had recently, it just goes to show that, you know, this is a sort of an ongoing problem with untreated sewage going straight into the sea. And again, it's sort of really unknown how much microplastic and plastics there may well be in that sewage as well. So it's there's a lot to sort of consider from those sources and those pathways, and that's again another reason why sort of the PPWG have looked at so how do we control those sources sort of within a Goal 10 report that we've done, and I'm sure there'll be a webinar on that shortly. And then lastly, sort of looking at those impacts of microplastics. The physical impacts of microplastics are quite evident. I'm sure we've all seen photos like this, and I do apologise, but it's the harsh reality that this is a photo from Sri Lanka of a fish with nurdles, obviously all filled up. Not only is it blocked all of its gills, reducing its ability to absorb oxygen from the water, but likely has filled its gut, meaning that it would eventually starve. And again, I'm sure you've seen photos, and especially on sort of documentaries like Blue Planet, where chicks' stomachs are filled with plastic because they seem to think these are things that they should be eating. So as you can see, this results in starvation within individuals, and also increased inflammation response, ultimately leading to mortalities. When there are these large pollution events like Sri Lanka, this can then lead to pretty widespread impacts within natural populations, and looking at sort of decreases there. So following that incident, a total of 470 turtles, 46 dolphins and 8 whales washed up on the Sri Lankan coastline, which all had nurdles within their stomach. Obviously, it's unknown if those nurdles obviously caused the deaths, but with the amount of pressures that the marine environment's under already, it's probably no surprise that it's probably a contributing factor to their deaths. So looking at the chemical side of things, and is one that's not always really considered, there is research out there to show that microplastics themselves are fairly inert and harmless. They can pass through the digestive system, especially within humans, fairly harmlessly. However, it can sometimes be those chemicals that absorb onto the surface of the polymers. Now, these can either be from dissolved within the water, so as I spoke about in Sri Lanka, the express pearl was containing a large amount of hazardous material on that, so it was unknown if that had sorbed itself onto the surface of those nurdles. But it also can be introduced to the plastic and to give it certain properties and characteristics. And in the example here, we have organic halogenated flame retardants. Now, these can be covalently bonded to the polymer, meaning that they do actually stick on quite well. But as well, these are dissolved onto them, meaning that they're quite readily sort of released at the same time. So these are kind of classified as these bromide flame retardants, as these BFRs. And there's research to show that these are quite easily released and can reside in organisms for quite a long time, becoming a persistent organic pollutant. And again, these BFRs, some of them have been identified to be carcinogenic. Ultimately, where they are persistent, there is that the progression of bioaccumulation without food chains. Given these microplastics are very small, it's going to be the smaller individuals and creatures ingesting them, and they will go up the trophic levels. And then also looking at the PBDEs, I'm not going to try and say that one out loud. Again, these have been widely reported within marine organisms, and obviously there's no reason they should be, flame retardants within there, and also then being identified within human milk, again, likely through bioaccumulation. The effects of these are still sort of quite unknown, and research going in there, but some have been identified as hormone disruptors. So it's also something else to consider. One headline which sort of caught the nation's attention is from The Guardian, was that microplastics were found in human blood for the first time. So this graphic here shows 20 sort of what they considered healthy volunteers. And you can see that sort of the different range and sort of compositions of plastics within their blood. So there was a mean concentration of plastics a mean concentration of 1.8 micrograms per milliliter within there. And looking down at those breakdowns, it's dominated by polymers like polyethylene and polymerized styrene, which is obviously used in food packaging and insulation within certain individuals. And then those PETs on the left-hand side, which are commonly used for water bottles. So it's obviously, this paper was purely just sort of an identification of the microplastics. There wasn't any idea of how that has got into the system for pathways. And the likelihood is that's either through ingestion, drinking water, or potentially from indoor air quality. But this also sort of concludes to say that it's unknown where these microplastics are sitting, whether they're in the blood plasma or they're being carried by specific cells. And the thought process is that those specific cells are likely to be immune cells. So that obviously begs the question of, if these immune cells are being preoccupied by a lot of microplastics, what effect that may have on immune response to diseases. So there's a lot of, I'm sure there's going to be a lot more research out there, and this is a sort of all growing as we're looking into it. And particularly nanoplastics as well, sort of the research of what impact they will have to human health. And then lastly, on the impacts is the biological impacts. Now, it's not one that's sort of really considered when you think about plastic, but this is looking at, again, the fact that vibros species, so bacteria species such as E. coli, can actually attach themselves to the microplastics. So this is seen within biofouling of large macroplastics, where again, sort of barnacles and certain seaweeds can attach themselves. And given the long persistent time of plastics, this can travel through, it will stay within the environment for long periods of time and leading to invasive species. And then similarly with microplastics, this can create a biofilm on that surface. So they have a very large surface area to volume ratio. And this creates this biofilm, meaning that pathogens can stay on that for long periods of time. Ultimately, these then get ingested. So while within that phytoplankton and zooplankton soup from sort of the large sort of mammals as whales, but as well through filter feeding bivalves. And then you can see that progression up through the food chain and ultimately leading to, those diseases again getting passed along. So we see again there from sort of point 4 with especially aquaculture, where we're looking at mussels and oysters. There obviously you can have a large sort of amount of these mussels all in a very small area. So as soon as one disease has been picked up on sort of the microplastics, this can spread throughout this whole the whole aquaculture area, not only leading to obviously the mortality of all of those mussels, but then quite a large economic loss for them as well. And obviously at the same time, if there isn't any issues with that population dying out, then that is then ingested by ourselves eating seafood. And again, those diseases potentially passing away through us. So I'll pass you on to John on kind of what's next for the PPWG and Oracle.
Thank you, Josh. So Josh has painted a pretty bleak picture there, which is the harsh reality of it, really. So following this webinar, the technical report for Goal 1 of the PPWG is going to be available to access and to read at your leisure. And we hope that the report acts as a useful resource in its own right, but also signposts to other really useful papers, books, and web-based resources as well, so that you can delve into the plastics subject and look at the impacts that plastics are having on the environment, ecosystems, and our health as well. We've also produced a report for Goal 10 of the PPWG, but that's not going to be ready for issue yet. So watch this space for that one. But that's focused on pollution prevention. So in particular, stopping plastics from entering watercourses and the ocean in the first place. And that report's going to be rolled out again following a webinar, which I think is scheduled for February next year. So, and just a quick thanks to Josh and to our colleague Kif Kalern, who I think is on the webinar as well, for pulling these reports together, and also to the wider PPWG for peer reviewing these publications as well. But I hope everyone finds them interesting and useful once they're able to access them. So yeah, as Mark sort of mentioned, they're going to be accessible through the UK and Ireland Spill website. And Mark set up this knowledge base, and we're going to be adding more information over the coming months to this knowledge base as technical reports and other information is obtained and produced by other members within the PPWG. So in terms of the work of the PPWG over the next few months, we're going to be working on the other project goals. And as Mark showed earlier, there's going to be a series of webinars on a monthly basis for the next few months, presenting the findings from each of those goals. And they're going to go hand in hand with the issue of the publications of reports and bulletins as part of those goals as well. So at Oracle, we're going to be continuing with our work with other members in the PPWG, in particular OSRL and ITOP, and with students at the University of Southampton who are sort of pictured here doing some initial research on some of the recovery and separation techniques. They're working hard as part of a group design project alongside the PPWG to essentially look at improving methods for recovery and separation of microplastics, and in particular nurdles from different shoreline types. We plan to continue to invest in plastics recovery and separation equipment to ensure that we can provide a rapid and effective response to plastic spill incidents. And we're also going to be completing more field trials around the UK in various locations to assess the effectiveness of different techniques and the effective techniques on different shoreline types as well. So through those trials, we're also identifying what equipment needs to be developed to improve our response around the country and around the world to different plastic pollution incidents as well. We're also going to be working with the International Spill Accreditation Scheme to develop a module for plastic pollution response. And we hope to be able to have that rolled out next year. And beyond the kind of goals of the current PPWG, we're likely to need to focus on the problems posed by nanoplastics. We know that obviously microplastics break down even further to form nanoplastics, and nanoplastics themselves are released into the environment as well. And we know that these smaller particles pose a real problem to water companies in particular, who, for example, cannot remove nanoplastics using established filtration techniques. So we need to ensure that nanoplastics are understood and addressed in the future. So there's still lots to be done. I think the take home here is sort of stay connected with us and with UK and Ireland Spill Association to stay informed and up to date on our progress. Thanks again to Josh for doing the hard work today and for helping pull the publications together, and to also Mark for giving us the opportunity to present the findings. But hopefully that's been interesting for everyone, but I'd encourage everyone to download the report and enjoy the bedtime reading. There's a few references on the presentation here, but the biggest reference list is within the report itself. So with that, thank you very much, and we'll hand back to Mark, and happy to take any questions if anyone's got any.
Now we've got a bit more to go yet.
Oh, we go on. Sorry about that, Mark.
If you unshare, I'll crack on. Great, thank you.
Good.
Well done, chaps. That was very good, very thought-provoking, very worrying. Anyway, so that we've done that one. So as John was saying, we're basically releasing with each goal that we produce a report for, we then have a webinar which associates to it. And so our next one is going to be our next webinar is on the 18th of January at 1500. So we'll be covering that with you all. Everyone who's registered and for this webinar will get an email which will have a link in it to where this webinar and its recording, where this report and where its recording has been filed within the website. So you'll be able to click on the link and it will take you straight to there. And feel free to download the information that you've got. So our aim, the Plastic Pollution Working Group aim, is that this body of information will assist all who plan for and have to manage a plastic pollution incident, be it like that in Sri Lanka or a smaller one which has occurred on your coastline in an unexpected way. We just hope that the documents that we're producing will give you a chance of coping with it adequately and putting in place response plans which are proportionate to the risk that your shoreline faces. It could be that it's just an accidental discharge from a plastic production company or just the result of debris washed up following a storm. But the worst thing that can happen is what happened up on the northwest coast of England, where effectively it washed on a beach and nobody was prepared to respond to sort it out and remove it before it went back in the sea again. I mean, all of us have got to reduce the plastic that we use. And what we use, we should dispose of correctly, and we should recycle whenever we can or seek alternatives wherever we can. But that is the ideal world. But as responders, our job is to help protect the environment and do what we can to solve the problems that are thrown at us. So what I'd like to do is to open the floor to any questions. I haven't seen any appear in chat, but what I'll do is, if you want to ask questions, please ask now. Is there anybody who's got anything that we can help with? Okay, well, there clearly isn't, and I hope that we, as I say, you'll get an email from us, flat signposting where you can get information on this. Please look out. We will email you when our next in advance of our next webinar, and you'll see hopefully quite a good stream of information coming from us between now and the middle of next year, which will be with the releasing of all our goals. I've got some questions coming in. Right. Paul Harold, he works for, I think was Public Health England, but it's now, I think, the UK Health Security Agency. Where do you see priorities for current and future research? Well, in a sense, Paul, what we're looking at is how do we deal with it as a responder, and we're limiting ourselves initially to dealing with microplastics, not nanoplastics, or really microplastics and larger, as you might see, the sort of stuff which might wash up on our shore after a storm. So we're looking at that, but our priorities are really to provide best practice guidance, which is accessible to anybody, so that they can draft their own response plans which are specific to their local environment for which they're responsible, such that if an incident occurs, maybe not necessarily on the scale of Express Pearl, which I guess is once in a decade incident, but they can prepare for a significant loss upon their shoreline. So that's our goal. We would love to work more in nanoplastics, but I think our priority is and the group's priority is towards microplastics and larger. Now, we are working with the different devolved nation environment agencies in the UK on their plans for preventing the stuff getting into the sea, which is really, if we can stop what's getting in, we can then start solving what's out there. So so that's that. What are the Philip Sontag, what are the primary techniques of coastal response? Do either of you geniuses want to get on with have a look at that?
Oh, sorry, I can answer that one if you want, Mark.
Yeah.
Yeah, so currently what we've been looking at, as part of that goal 2, is really it's an assessment of like you would with sort of the oil industry, of your SCAP model and the idea of what's your shoreline type and also what's your contaminant and quantity. What we've gone towards mainly at the moment is that vacuum recovery. So you might have seen some of the photos when John was talking. We sort of got these cleaners that basically just lift off the surface. So where the plastics tend to be a lot lighter, either with on the sands or shingle, we can just lift straight up and vacuum recovery. Obviously, it saves the idea of sort of that mass excavation, which not only is quite damaging in some areas, but also got sort of that higher CO2 input to it as well. But I said it's really dependent on those shorelines. Other things we're looking at is those sieving techniques, if we're able to scrape off areas so to a certain level and then put those in sieves. So we're reducing the amount of substrate that we're taking off the beach. And again, the amount of impact that we're causing as well, which is again another one of our goals, is looking at that balance between what we're doing is responding to the plastic and what the impact of that work is as well. I think that pretty much covers most of the techniques at the moment.
The other bit I would say that one thing we've also been using is we have used some of the products which are used in oil pollution response, particularly coastline response. We have tried using simple skimmers, which are partially effective. We've also used triangular vacuum heads, which suck stuff into a which use a vacuum system to suck it up while the product is still in the water, which seem to be quite effective. We are doing more trials next year where we're going to use a broader range of equipment to see to update that, and that will all be published and shared. The next question was, is there any evidence that the fishes in the UK are contaminated with microplastics? Well, I would say they definitely are, but to what degree, I don't know. John, any light on that?
CFAS would probably be best to answer that. There is reference in our report to the extent to which fish generally can be affected, and there's reference to specific papers within our report. I can't recall if any of them are UK specific, but CFAS, I know, are sort of working on that aspect on a regular basis. So perhaps we invite them back at some point, Mark, to give another presentation.
In the next webinar, we will touch on that, which is being done between ourselves and CFAS. There is no doubt that it has an effect. As Josh and John have pointed out, I mean, it's in our blood. Nanoplastics are in our blood. If it's in our blood, well, then I'm afraid the microplastics are going to be in the fish, because there's so much of it out there. And unfortunately, whilst it might be reducing slightly, it isn't reducing sufficiently. Do you use any software for modeling plastic drift? Oh, now that's the holy grail. That is the holy grail of spill response. However, it's not all gloom and doom, because innovative companies like Orbital OES, RPS and CGM are all working on what is the holy grail, which is to come up with a solution which will tell you where there's been a plastic spill, and it will trace it back to its source, so they can be prosecuted by the regulators and everyone gets paid. What we are doing, what is happening is there are adaptations of existing marine oil spill pollution software, which is being tweaked and modified to allow it to track plastics. So if there are large releases of plastics, such as that which would have come from the Express Pearl, we would have been able to track exactly where it went, because there would have been sufficient refraction of light to highlight the loss of the plastic. Now, I am going to be, one of the papers which is coming out as part of the goals of the group is a discussion of what we can do. All we know is that with the prolific addition of satellites in the sky, particularly the Starlink network, which are at actually quite low level, the cameras on those satellites are particularly high definition, and the experts are playing with more stuff, so we can identify more which is floating on the sea surface. And if we get their right angle, and if we get there's sufficient clusters of plastics, we're starting to be able to see them. So watch this space, but there's a lot of brighter brains than mine which are working on it. Have you come across or looked at rubber and specifically dust debris from tires and toxic? Go on.
Yeah, so I was going to say, sort of kind of alluded to in the presentation and a bit more detail as well in our report. There's definitely evidence for that. It's not something that we've specifically done ourselves. A lot of this goal one is sort of large scale literature research on it all. But so there's definitely that evidence for rubbers and sort of that thermoplastic rubbers that are used that are washing it through into the drainage systems, basically. Like I said, not on the specifics too much.
I think there's some really good information available through OSPAR. They looked at the sort of European catchment and found basically that tyre wear and the microplastics from tyre wear was the biggest contributor to microplastics. So without doubt, that is a huge source of microplastics in the environment. In terms of the specific compound that's been sort of raised there, I'm not aware that it's been looked at specifically in terms of research generally, but it's certainly something we can add to the mix. And I think, again, others like CFAS might be able to look in more detail at the potential issues posed by specific chemicals.
And I think obviously the point of all of this work so far is that this is really the start point for us and the PPW and the group, is that there's going to be a lot more research out there, and all these, there are fantastic questions, and these are the ones that need to be asked. So, we're going to be looking at sort of reviewing these documents as we go, and as more literature comes out.
Yeah, we are actually we have started at one of the early outcomes of our literature research was the considerable volume of harm that that tyre wear is doing. And at the moment, on our most roads in most countries, I'm not saying it's all countries, but most roads in most countries, it goes into a drain. The drain then goes into a river, and you've lost it. What there is talking about within the Environment Agency is on key routes where there are more sensitive environments, is actually putting filtration systems within effectively interceptors within some of these drainage systems to capture the microplastics as they're being flushed down the drains. How long that will take to be affected, heaven only knows, but we are looking at that. In terms of the next question, what options for disposal of recovered plastics are there? Is incineration via energy from waste preferable, or can other recovery methods be used? Right, this is one which I'm specifically been looking at, and I've been talking with the various waste recycling bodies on that. Now, what they would require, so if we had a major incident, we would on site do a coarse segregation of it. We would then hand it to a waste management. We would then deliver it to a waste management company who would segregate as much as possible, such that you could take, say, the polypropylenes and you could easily recycle it. Probably the rest of it would then go to energy from waste, because it would be classed as a mixed plastic waste, and it would therefore provide energy from waste, which is better than it being stuck in a hazardous landfill. But we are talking to waste management companies on this, and things are moving. The next question from Sean, are any government bodies such as the Environment Agency involved in proactive programs to prevent plastic entering rivers or collecting them if they have already reached rivers? Right. Pregnant pause means things are supposed to be happening, but you can read into the pregnant pause as much as you wish. So you pregnant pause. However, one thing we have been consulting on is with SEPA, who are running their own, who've produced a fantastic document which is their new plastic strategy based upon preventing it getting into rivers and estuaries. And they've done some really good work on that, as has the Northern Ireland Environment Agency, who've got a really proactive educational program. The issue is, if people, one, bought less plastic and there was less plastic in the supply chain, if government produced a plastics recycling scheme, such as that you see in most supermarkets in Europe, where you take your plastics, you chuck it in the machine, and out comes up comes a little wodge of cash, not a great deal, but you feel you've done your bit and you've got a benefit from it, then it would reduce immediately the amount of plastic which is in the environment. That our government have been talking about producing extended producer responsibility, which is current in there's 12 countries in Europe which have it now, and that means that there's cash to play with to allow you to force to recycle, make recycling easier. Other than that, which you have schemes such as that which the EA are working on at the moment, and EA have a plastics team which we are engaging with, who are really trying to put the burden and responsibility on through education of the consumer to act more responsibly. Unfortunately, I think that's too slow a process, and there needs to be more government, more environment agency involved in far more proactive programs than they have at the moment. However, we are working alongside them to try to boost their level of proactivity and their level of output such that some of these programs can be adopted. What we would like to see from the Plastic Pollution Working Group is some of the very, very simple things, such as in one of the pictures which Josh showed you, which was effectively a fenced dam across a significant water outlet coming from a city, which was capturing tons and tons and tons of microplastic before it enters the oceans. However, they're great, but you need to manage them, and you need to send a vacuum tanker down every day to go and suck out what it's gathered. Otherwise it all seeps through, or it blocks up, or it just the fence gets vandalized and broken and it all washes into the sea. So there's lots of things which people can do, and one of our goals is to share some information about what can be done, so councils and people who look after outflows into rivers and estuaries can prevent it getting there. So sort of that answers most of those questions, but if anyone else said anything else, let us know. But the next webinar is going to be on the 18th of January at 1500, and we'll be emailing you all about it with links to today's webinar and also the source document for it. So in the meantime, I'd like to thank everyone who's attended. I'd love to thank very much John and Josh, who've done a fantastic job presenting it. It's been great. It's been very thought-provoking, but it shows you just the challenge of what we've got to do, and we're all motivated to help people get on with it. So without further ado, thank you very much indeed, and have a good day. And we won't see you until the new year, so I suppose it's a bit early, but happy Christmas, and we'll see you in the new year.
Thanks
very much.
Thanks, Mark. It's not all doom and gloom, everyone. Don't worry.
No, it's not. No. We're working hard on it. Thanks very much.
If anyone does have any questions on the report once they read it, then do contact us directly. That's no problem.
Yeah, the links to their address will be on the document, so you'll feel free to reach out. Thank you very much indeed.
Thanks, everyone.
Cheers. Bye-bye. Bye-bye.
Bye.